Page 116 in your textbooks, and we're going to start by looking at numbers 11 and 12. They're on page 116, so it's probably the last thing you did for homework, but it's the first thing we're going to look at today. Got a couple of literal equations here. Again, not particularly challenging literal equations, but whatever. Number 11, we've got the, go and put the bottle down on the floor there for me, Abby. We've got a 36a squared x minus 25b squared x equals 6a positive 5b. What do we need to do to solve for x, Brandon?
You can factor out that x.
Good, we've already got the x's on one side, the non-x's on the other. They did that step for us, so we just factor out the x, and when I do, I'm left with
X times 36a squared minus 25b squared and equals that.
That equals 6a plus 5b. Then what did you do?
I treated it as a conjugate because it's different than squared.
Okay, so you factored the difference of squares into a pair of conjugates, either a little bit more factoring.
6a minus 5b times 6a plus 5b.
And then maybe the other side, we don't have to necessarily group it, but if we do, it might help us to see things a little better.
I can't, so the 6a plus 5b.
And technically, what's still left over here, though?
1.
The 1 that comes in front, I'm just going to write it off to the side, though, and I still have to do what to get x by itself?
Minus 6a minus 5b.
There we go. So 1 over 6a negative 5b, our answer, and we could say, of course, that 6a doesn't equal negative 5b, or, if you wanted to, go and divide away the 6 and say a can't equal negative 5b over 6. Any of those would work. You could even leave 6a plus 5b can't equal 0. It just takes longer to write, but less brain power. How many had this answer on number 11? Had this answer for 11. All right, questions on 11. Factoring out the x, maybe a little bit more factoring than some canceling questions. All right, number 12. This time they did not do what they did the last time for us. What do we need to do first on any literal equation, Michael?
Isolate.
Well, not a literal equation, because we've got, assuming we've got more than one x. Now, if there is only a single x in the problem, of course, we'll get it by itself. But here we've got lots of different x's. So I told you we want to get all the x's
On the same side.
on the same side. And right now, of course, they're not. Thoughts?
Move the 5x over.
As a...
Set it equal to 0, negative 5x.
Okay, make it a negative 5x. And at the same time, we had a positive 3 over here. We should probably move that over as a...
You can move to negative 3.
Negative 3. All right, well, we got all the x's together. Now what?
I got x is equal to all real numbers.
Okay, that's not quite what we needed to do here. Genesis? Yeah, factor out the x. And what are we left with in parentheses?
5c squared d squared minus 5c squared equal minus 5.
Good, and technically we see we could also factor out a 5, couldn't we, class? But does that really help me do anything on the other side if I factor out the 5? Not really. So it's not a problem if you factored out, also not a problem if you didn't. This really doesn't factor anymore, even if it did. Like here, factoring further made sense because there was a binomial over here to cancel. Even if this did factor, when all you got's a negative 3 anyway, we might as well take the easy road and just...
Divide away that entire thing.
Yeah, so we end up with what?
5c squared d squared minus 5c squared minus 5 over 3. We put the negative on it.
Good. The 3 on the top, the negative out front, then that whole 5c squared d squared minus 5c squared minus 5 all in the denominator. How many had that ugly answer for number 12? Okay, questions on this one?
I just factored out the 5 on the side.
Right, okay, so yeah, if you had the 5 and then that left over, I guess we'll write it that way, then that would also be the same thing. That would also be correct. Anyone else have that answer, perhaps? Okay, several of you, okay. Yeah, same thing, though. All right, Audrey, question? All right, Michael, question.
I just factored out the 5x before moving it over.
Before moving the 5x over?
Yeah. I factored out 5x and then I canceled both and I got...
Oh, okay. Do you see what you should have did?
Yep.
Okay. All right, let's turn back to page 82 now. Page 82. A couple of algebraic representation where we had to solve for the variable when we were done. And go ahead and read number 17 there at the bottom of page 82 for us. Let's go to Abby.
The quotient of 3r and 4 equals 6.
How do we write that?
3r over 4 equals 6.
And what would I need to do to solve?
You can cancel the 4 and 6 to get 2 and 3.
Ooh, careful. If we were multiplying, then that's what we could do, but it's across an equal sign, so no. All right, what should we have done instead?
The means and the extremes.
Right, if I put this over 1, I could cross multiply the means and the extremes. That's an option for sure to get.
3r equals 24.
And then that would give me r is equal to 8. We could do that. Okay, that's a creative way to do it. I actually like that because we're going to do so much with proportions next year in geometry. It's good that you see the proportions now. Those who are in geometry can testify. That knowing laugh from Kendall. But there's another way we could have solved this. Audrey, now you were in geometry. Did you see the proportion method also? Okay, that works. Anyone a slightly different method to get the r by itself?
I just multiply the 6 by 4.
Okay, so we say multiply both sides by 4, which is essentially the same thing to end up getting, that 4 cancels. This 4 doesn't. To get the 3r equals 24, and again, r equals 8. What about multiplying? Remember we said if I wanted to knock out the 3 and the 4 at the same time, I could multiply by the reciprocal 4/3. That's the same as dividing the 3/4 away, right? But we never divide fractions, we multiply by the reciprocal. If you multiply here by 4/3, now we can do some canceling here. There's our 8. So a couple ways we could have solved that. How many regardless got 8 for your answer and got that equation? Good. Number 18, how would we write the product of 12 and w plus 2 is 36? Kendall?
12 times the quantity w plus 2 equals 36.
There we go, 12 and then in parentheses w plus 2 equals 36. And a couple directions you could go here to solve. What did you do?
You can divide it with 12.
I like that. I'd rather do that than distribute the 12. Now, nothing wrong with distributing 12, but I get little numbers if I divide the 12. What do we end up with then?
W plus 2 equals 3.
And it couldn't be easier. W just equals
1.
1. Or if you distributed the 12, 12w plus 24 equals 36, subtract away the 24 to get 12w equals 12, you still get w equals 1. So either way, same answer. It's just smaller numbers if you divide the 12 out the outset. How many regardless got the 1? How many like Kendall divided the 12 away out at the beginning? How many distributed the 12? Again, nothing wrong with that. That actually follows the steps a little more accurately. Just this gives us an option since there's nothing else here but the distribution. Question, Brandon?
I did the wrong problem.
Oh, which one did you do?
It wasn't the top. 17 and 18.
I believe when I sent the homework, I said page 82, numbers 17 and 18 at the bottom. Did I know that at the bottom? Anyway, all right. They were a lot easier, these two, than 17 and 18 at the top. Though, good review of inequalities, I guess. What?
We've already done those.
We had already done them, yes, but maybe you like doing them again. It was just such a fun time. It's like, let's do it again. I don't usually have you redo problems, but it's been a while. He may have forgotten me, though y'all didn't. Maybe his memory's just not as good as Chase's. All right, let's review some stuff we started talking about yesterday because I introduced. I guess I'm schizophrenic now. Me, myself, and I. Anyway, I introduced to you a new group of equations that no longer have one answer, but have 2 answers. What type of equations, besides absolute value, because they don't always have 2 answers, right? Could have no solution, could be all real numbers. But what type of equation we talked about yesterday that will always have 2 answers, class? Quadratic equation. We said a quadratic equation always has 2 answers because what makes a quadratic equation quadratic, Audrey? X squared is the highest power. We said there's 2 types of quadratics. What are the 2 types of quadratic equations, Maddie? Good, complete and incomplete. And what's the difference between those 2 types of equations? Genesis, do you remember?
Complete one's not.
Right, but what makes a complete quadratic, quote, complete?
The x squared.
Well, the x squared makes it quadratic. Michael?
I don't know, was it here?
You came in late and didn't end up watching the video, okay? You've got to watch videos. It really helps with quizzes and stuff. Brandon?
The x to the first.
An x to the first as well. So if you have an x squared, it's quadratic. If you also have an x to the first, now it's complete. Without it, it's incomplete. Or we said it's a pure quadratic is another name for it. What's the proper form for any quadratic equation? The standard quadratic form. Abby?
Ax squared plus bx plus p equals c. Or plus c equals.
We're going to see this today equals 0. So the quadratic form is to have your x squared, then your x, then your constant, and then equal to 0. Now for our purposes though, we said that the b equals 0 in an incomplete or a pure quadratic, which is why we don't see the x term. So what we would do is we'd isolate the x squared, getting it by itself and take that square root. We really would like it if a is a 1. That really makes life easier if it is. But that's our quadratic form. We're going to look at that a little bit more today as well. But for the incomplete, I just said it a moment ago, class, for an incomplete quadratic, step number 1 is to isolate the x squared. Good, Maddie, remember she mouthed it there to me. I think I may have even heard breath come out of her mouth. Isolate the x squared. And then once we've isolated the x squared, make sure we take the square roots of both sides. Because how many answers? 2. But for a pure quadratic, generally the answers will be positive, negative, whatever we wind up with. So let's take a look at the homework, page 95, numbers 12 through 20 even. Now at the end of the hour, as you're turning to page 95, at the end of the hour yesterday, I referenced something that I thought I would be teaching today, and I planned on teaching today, and I realized there was one of those in your homework. So I apologize for number 20. We were a little ahead of ourselves assigning that one. Here we go, being schizophrenic again. But let's at least 12 through 18 we should have been good with. And thankful for our calculator on number 18. So we have a 3a squared, positive 11 equals 254. Incomplete. I have the a squared, it's quadratic, but there is not an a to the first. So to isolate the a squared, we're going to have to do 2 things. And what are those 2 steps? Michael?
You gotta take away the 11.
To get...
You get, let me see what I wrote down.
Just try to run it in your head.
Yeah. No, hold up. It's 243.
There we go. That you could do in your head. And then we need to divide away the 3. And you might even be able to do that in your head.
It is 81.
81. And then once we've isolated the a squared, class, we take the square root of both sides. And what do we get for a, Michael?
9.
Minus a point.
-9.
Positive, negative 9. How many positive, negative 9? 4, number 12. Number 13, we had a 3n squared. Negative 4 is equal to 44. And what do we need to do first here? Kendall.
You add the 4.
To get?
48.
And then we,
Divide away the 3.
to get?
60.
And then we,
Take the
to get?
positive negative 4.
How many positive, negative 4 like Kendall did on number 14? Excellent. Number 16, we had a 16, w squared, negative 12 is equal to 48. What we need to do here, Brandon,
Add 12.
to get,
60.
then,
Divide 16.
oh,
15.
that's not going to divide by 16 evenly, is it? What's that going to give us?
15 or 4.
15 fourths when we reduce. Don't go mixed number. That's w squared, and then I've got a square root. Take the square root of both sides, and that'll give me w is equal to, well, you can never have a fraction, right, class? We said we have to take the root of the, but can I take the square root of 4?
Yes.
Yeah, I can. Square root of 4 is just, can I take the square root of 15? I don't care, it's a numerator anyway, I'll just leave, but that's only one answer, so positive, negative out in front of the fraction. How many have positive, negative? Square root of 15 over 2. All right, questions on this one? All right, number 18, big number, 35b squared negative 13 is equal to 5,027. I'm not sure if this is someone's idea of a cruel joke, but the first thing that we need to do, Genesis, is, and when we add the 13, it gives us 5,040. Then we need to, and I'm so glad you have a calculator, Genesis. What did you get when you divided by 35? 144. Oh, that's not so bad, because then when I take the, I get, okay, that worked out well. How many positive, negative 12 for number 18? And then number 20. This is the one that I showed you at the end of the hour yesterday, that if we had x squared equals, say, 13, I would take the square root of both sides, right? To get x equals positive, negative 13, right? But what if instead of an x squared, this was an x minus 1 squared? Well, then x minus, positive, negative square root of 13. Then that means that x minus 1 would equal positive, negative square root of 13. And then I have to move this over as a positive 1. That's what we had to do here, except they didn't have anything squared. they had d squared positive 10d positive 25 equals 13. Well, question for you. What is that thing? Perfect square trinomial. Perfect square, positive, even. And a perfect square trinomial class factors into a binomial squared. And a binomial squared, just like an x squared, you could take the square root of both sides. And when you take the square root of d minus 5 squared class, you just get d minus 5. When you take, or try to take the square root of 13, you get nothing. You just get positive negative square root of 13. But d isn't by itself yet. I've got to move the 5 over as a positive. But there's nothing to combine it with. It's just a plus 5. And there are your two answers. Now, the book did mention if it came out, if it didn't come out evenly, to write as a decimal rounded to the nearest hundredth. I didn't expect to do that. I don't even think, did any of you even notice that was in the directions? You did. Okay, way to go, Michael. All right, the rest of you did not. For instance, we left this. We didn't get the decimal here. I suppose we could have. Tell you what, on your calculators, take the square root of 15. For most of you, you simply type 15 and you hit the square root button, and boom, it pops up. For some of you, you have to hit the square root button, and then it'll put up a little parenthesis, then you type 15 and hit equals. So some of us, it's 1, 5 square root symbol, some of it's square root, 1, 5 equals. But what is the square root of 15? 3.872, blah, 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 blah. It's going to literally go on forever without repeating or ending. Now, divide that by 2. 1.936. Notice that round to the hundredths place. That'd be 2 decimal places. So 1.94. So it's approximately positive 1.94 and negative 1.94 for this answer had you done that on number 16. Over here, it's going to be a little bit more involved. We need to take the square root of 13 on the calculator. Once you get the decimal, add 5. What do we get? 8.601? 8.61. 8.605. That's what I was trying to get. 8.605 rounded to 8.61. Okay, that's all. I was trying to make sure I got the correct number and then we rounded it. But then also, notice we can't just do positive negative like we did here because it's a negative square root of 13 plus 5. So now take the square root of 13 again, but stick a negative sign on it once you've got it. Then add 5. And what's our other answer?
1.394.
1.394 rounds to 1.39. And there are our two approximate answers. Whoa. Oh, I copied something wrong. D squared plus 10d plus 25 becomes a binomial squared, but it's not d minus 5 class, it's d plus 5. So when I move it over, it doesn't become a positive 5, it becomes a negative 5. And my answers, by the way, end up being negative those. It's like, wait, I messed something up, that's why. Gavin's screaming at his computer right now, it's a plus, it's a plus! I got you, Gavin, I'm sorry. Hey, at least I caught it eventually. Better late than never. But yeah, good job, Gavin. Brecken's like, what happened? All right, questions on this? The bigger thing, okay, even beyond the calculator stuff, okay? Do we see how to take PST to binomial squared, and then you just take the square roots? Questions on that? Turn over in your books to page 97. So just flip one page over. You're going to get practice with 2 of those. I want you to do 29 to 32. 29 to 32 back on page 97. A couple of them really straightforward, and then a couple of them have that PST, turn binomial squared, take the square root. Let's see how we do with those. By the way, anyone get this answer by any chance? Number 20? I didn't think so. You did?
No.
Oh, you didn't? Okay. All right, I was just curious because, like I say, I hadn't planned on getting that far yet. That was supposed to be today's concept. So again, I apologize for not better preparing you for the homework. 17 people just unsubscribed from my YouTube channel. Just like that. It's okay. That poor calculator. Maybe you should ask for a new one for Christmas or something. Parents will look at you weird. What do you want for Christmas? A new calculator. What's wrong with our daughter?
She's generally like that.
Your brother holds you in very high esteem. Is this no, you're in Bible together as well. So okay, are y'all in any other classes together, or is it just this one? We're in the Bible too. You and your brother slaving away in physical science. And is that it? Sure together?
For the record, I let her finish first.
Actually, I finished first, so.
There's no ego in here. Audrey's like, yeah, but I got all the answers right. Smiles that angelic smile. Kendall's over there like a fallen angel. Some friend you are, Kendall. Come on, you're mean. Ouch. She always say things like that about you? All right, let's go and take a look at number 27. Really straightforward here. 4b squared minus 7 equals the 137. 2 steps. First of all, Michael.
Take away the 7, and you get 144.
Okay, I was thinking add the 7, yes, and you do get 144. Take away the negative 7, right?
Yeah.
And then you
divide it by 4.
To get b squared equals.
36.
And so b equals.
Positive negative 6.
How many had positive negative 6 for number 29? Or number 27, whatever number that is.
9.
29. How did I get 27 from? Number 29. This one we just did on the board. All right, number 30, Genesis, 2 steps to solving this. That's a plus. It's just a really big plus sign.
Subtract the 10.
Subtract the 10 to get.
2y equals 32. 2y squared equals 32.
All right, and then what?
Divide by 2.
To get.
Y squared equals 16.
And then.
Y equals positive negative 5.
There we go. Are we always going to get nice, easy numbers like this, class? No, we've already figured that out. But they're being really nice to you here on 29 and 30. But they don't write your quizzes, do they? All right, number 31. We have the y squared positive 4y positive 4 is equal to 16. And on the surface, you look at this and say, this is not an incomplete quadratic. This is complete. You've got a y squared and the y to the first. But I could make it act like an incomplete quadratic if I took this entire trinomial and rewrote it. How, Maddie? Y plus 2 quantity squared. How many did that initial step of writing as the binomial squared? What then do we have to do, Maddie? To get? Minus a point? Positive negative 4. And then to finish the problem out, subtract the 2 to the other side, or move it over as a negative 2. So there's 2 problems here, 2 answers for y. One is 4 minus 2. The other is negative 4 minus 2, or negative 4 negative 2. What is 4 minus 2, class? And what is negative 4 negative 2?
Negative 6.
Negative 6. How many of those 2 answers? 2 and negative 6. All right, so if you'd be able to finish it out, questions on that. All right? Redo number 32 at your seats very quickly. Now, if you feel like, nope, I nailed the last one, I know I'm good on 32, just sit there with a smug look on your face. But the rest of you, go ahead and redo number 32. Using 31 now as a model, now that we've seen it a couple times. was gonna tell Michael he needed to work on his smug look, and then I noticed Abby's done. Like his look would have been so much smugger if she'd been working still, but no smuggage. All right, that's a word I just made up. Smugosity. All right, number 32. What do we need to do on number? I don't even want to write that down. I want to write it down. How, Brandon?
N plus 7 squared equals 9.
There we go. How many went straight to that though? N plus 7 quantity squared equals 9. And then what do we need to do?
Take the square root.
On both sides, right?
N plus 7 equals positive -30.
And then how do we finish it out?
Subtract 7, so n equals 10 and -4.
Well, you're right about the -4 because 3 minus 7, or positive 3, -7 is -4. Good catch. -3, -7 would be -10, and there's my other answer for n. And again, all of these worked out nice, easy integer answers, which is wonderful. How many got those on 32 just now when you redid it, or before when you did it the first time? All right, feel like we understand this thing now if we had to do it, which hopefully we don't have to do very often. All right, got 4 more for you that aren't like, well, actually, no, one of them is like that. I lied. Never mind, 4 more for you. I gotta look at my notes more often. All right, got a 2y squared. -8 is equal to 6 -5y squared. 4n squared -n squared equals 36. Couple more for you. You keep working. I just realized I probably cut off something there a minute ago on the end of the chalkboard. My bad. Sorry, Brecken. Sorry, Gavin.
Are we doing decimal notation?
I want radicals, but if you want to calculate decimal as well, yes. Go ahead and do it if you finish early. Figure what the decimals would be. I get 2 decimal places, should be plenty. But normally I'm looking for radical values. But they're both good. They're both good. They're pumpkin pie. Twice as much money. Twice as much money. Twice as much Pepto-Bismol. Anyway. Man, I need to sponsor my YouTube channel. Give me a shout out. Brandon's finished, Michael's finished, Maddie's finished. Audrey's finished. All right, let's take a look at these together, and I'm going to have Genesis take our first one. Genesis, what do we do?
I got the -5 on the same side and the -8 on the other side to get to 7y squared equals 14.
Good.
Divide away to 7.
To get?
Oh, because you're gonna write y squared equals positive or negative.
Well, not yet. Just y squared equals
Oh, y squared equals 14.
2. You divide the 7 away.
Okay, so
Right, yeah, and that gives you the 2. And then you take the
square root.
square root, and that gives you,
Y equals positive or negative 2.
well, what's the square root of 2?
Square root of 2.
Square root of 2, yeah, we don't know. So we're going to leave it this way. We could round off. Now, they're both going to be the same decimal value. It's just positive, negative. What is the square root of 2 approximately? Anyone? 1.41 approximately. All right. Anyone else get that decimal value for the square root of 2? All right, questions? All right, look at the next one. And Michael, what do we need to do here?
You need to subtract the n squared. You get 3n squared equals 36. You need to divide away to 3 to get n squared equals 12. And then take the square root to get positive negative 2 square root of 3.
Excellent. Positive negative 2 times the square root of 3. Now, strategy tip here. When you go to plug this in the calculator, you can do 2 times the square root of 3, or many of you, square root of 3 times 2 to get your decimal. It'd be easier just to take the square root of 12. That's faster, right? And what do we get for the approximate values of n? 3.461 maybe? 46.
3.464.
4. Okay, so approximately 3.46 positive negative that. All right, and there would be our answers there. How many have the positive negative 2 square root of 3? Anyone else get the positive negative 3.46 for your approximate decimal? Okay, questions? Look at the next one. Audrey, what do we need to do?
You distribute
To get?
18 minus 6x minus 1
And then here,
x squared.
3 things.
Oh, squared first, squared last. Multiply it.
There we go. Square the first square less multiply double to get.
X squared minus 6x plus 9.
All right.
And then you combine to get negative 6x minus 17. I mean positive 17.
Okay. Of course, still equals the x squared negative 6x positive 9.
And then you can cancel the negative 6x.
Yeah, I would have actually done that up here, so I wouldn't have had to waste the time writing them down here. But hey, it's not a problem as long as we eventually catch it. They cancel away.
Move the 9 over to x squared equals 8. And then you take the square root and add 2 times the square root of 2.
Positive, negative, that, right? And then what's the approximate values for the square root of 8?
2.82.
2.82. Positive, negative 2.82. Anyone else get the 2.82?
Around
2.83. Anyone else get positive, negative 2.83? All right, questions on that? And looking at the last one, again, here's an example like we saw before where it's not really incomplete. One might argue this one wasn't, but because the x's ended up canceling out, it really was incomplete. This one isn't. We can make it behave like an incomplete quadratic, Abby.
You can rewrite it as x negative 5 y squared is 16, and then get the square roots of x negative 5 equals 4, positive negative 4. And move the 5 over as positive 5, so x equals 9 or 1.
There we go, 4 plus 5, 9, negative 4 plus 5, 1. And how many got those answers for the last one, those who made it that far? All right, questions at all on these incomplete, for the most part, quadratic equations? All right, incomplete quadratics, they're all the same way. Isolate the x squared, take the square root. Complete quadratics, there's a number of different ways to solve. And there's the next section in your notes. We're going to spend the next few days working on these, solving complete quadratic equations. Solving complete quadratic equations. Roman numeral 1 in this section, there will be 3 methods here that we'll talk about. But method number 1 is the factoring method. Method number 1 to solving complete quadratic equations is to use what I call the factoring method. Why? Because we're so good at factoring. Why not? All right, method number 1, the factoring method. If you won't write this down, this really is first choice. This is the easiest way to solve most quadratic equations. That's why I teach it first. Now, I say most quadratic equations. You can't use this on all complete quadratics. That's the downside. If you want to jot that down, that wouldn't be a bad thing to write. You cannot use this on every quadratic equation. It will not always work. There are some things you just can't factor, right? Like even as we were practicing factoring earlier, every now and then the textbook would sneak in a prime polynomial on us. We couldn't factor it. But most of the quadratics we'll look at, this will be our first choice at least. Step number 1, under solving complete quadratic equations, is to set the equation equal to 0. That's the proper quadratic form for a reason. Ax squared plus bx plus c equals 0. Get it equal to 0. Get it in proper quadratic form, you might say. So for instance, if I had the equation x squared positive 7x is equal to 18. Well, this isn't set equal to 0, is it? I need to make one side or the other a 0. Here's your rule of thumb. You want the x squared positive. So I could move both of these over and it would be equal to 0 over here. But I don't want a negative x squared. I don't want that first term negative. So the easier choice here is to bring the 18 this way. To get x squared positive 7x class negative 18. And now there's nothing over here. It's now equal to 0. Does that make sense? Or the way I taught in Algebra 1, subtract 18 from both sides. Step number 2, factor completely. That's why we call it the factoring method. Step number 2, factor completely. Oftentimes, backwards FOIL. Often, backwards FOIL. In fact, this is why we call this type of trinomial a quadratic trinomial, is because it shows up in quadratic equations. The equations had the name first. The trinomial became nicknamed because it was used so often, or appeared so often in these quadratic equations. But step number 2, factor completely. Often backwards FOIL, but word of caution, don't forget common factors. Don't forget about common factors. Okay, factor those as well. Here there is no common factor. Here we just backwards FOIL. And so on the left-hand side, class split up the x squared, x and x. What does the negative sign tell me? Signs are different. One's positive, one's negative. How to split up the 18 to get a positive 7?
9, 2.
Positive 9, negative 2. So I've now factored the triangle. Of course, still equal to 0. Well, you'll remember from Algebra 1, we said if something times something equals 0, one of these two somethings has to be a 0, right? One can be whatever you want as long as the other one's a 0. Or this can be whatever you want as long as that one's a 0. Or they could both equal 0, correct? But if two things multiply give 0, one or both of the things must be 0. Well, look what we've got. We've got one thing times another thing equals 0. That means that either x plus 9 equals 0 or x minus 2 equals 0. Or both. That's step number 3. Set each factor equal to 0. Set each factor equal to 0. Set the x plus 9 equal to 0, set the x minus 2 equal to 0. And then step number 4, solve for x. I mean, move the 9 over class, you get x equals negative 9. Move the negative 2 over, you get x equals 2. And there's my answers. Pretty easy. I will say a lot of students will end up doing these last couple steps kind of all at once. I'd make sure you at least show the factors, and of course write your answers. But if you wanted to do this step mentally, especially those who remember doing this from Algebra 1, you're certainly free to, or as you get more comfortable with it, doing it more. Write this down if you would, please. 6x squared negative 7x is equal to 8x. 6x squared negative 7x is equal to 8x. Is this complete or is it incomplete, class? Complete or incomplete? Complete. It has x squared and it has x to the first, so it's a complete quadratic equation. With complete quadratic equations, class, we don't isolate the x squared and take the square root. We start by setting the equation equal to one side or the other can become 0. It doesn't really matter as long as the x squared stays positive. In which case, class, we're obviously going to move the 8x to the other side as a negative 8x. We're just going to combine with the negative 7x to get what here, Kendall?
Negative 15.
A negative 15x. Of course, we still have the 6x squared and the negative 15x, all equal to, class, 0, which was the goal. Now, you'll notice I've got an ax squared where a is 6. I've got a bx where b is negative 15. I don't have a c. I don't have a constant term. That's okay. Still a complete quadratic. But now that means we don't have a trinomial, so we can't backwards FOIL. How will I factor this instead? Genesis?
Well, no. No x.
I could pull out an x. I could actually pull out more than just an x, though.
A 3.
I can pull out a 3x. And what's going to be left in parentheses when I pull out a 3x?
2x.
Again, I've got a factor here, I've got a factor here. One of them, or we'll say both of them, would be equal to 0. So that's my next step. Say that 3x equals 0. Say that 2x negative 5 equals 0. Here, I don't move the 3 over, class. What do I do with the 3? Divide it away. But what's 0 divided by anything?
0.
So 0 divided by 3 is 0. Here, 2 steps. First, move the negative 5 over to get 2x equals positive 5. Then divide away the 2 to get x equals 5/2, 5/2. Again, you may be able to do these steps mentally. If not, that's fine. If so, more power to you. So sometimes backwards FOIL, sometimes just common factors needed on your complete quadratic equations. Questions on those? Write this one down if you would, please. N squared, positive 11n, positive 30 is equal to 0. Sometimes the equation already is equal to 0 for you, just because people are nice like that. And so you get to skip step 1. You get to go straight to step 2, which is to class factor completely. What'll I do here, Maddie? Okay? I promise I didn't do that on purpose. All right, and so let's try to do this mentally. I know I'm going to set both of them equal to 0, right? And when they're both equal to 0, I'm going to have to move the 6 to the other side and the 5 to the other side. So what am I going to get for my 2 answers for n? Do we see how we can do that set equal to 0 step mentally? The other way you could do it if you really wanted to show it, just write a little equal 0 here, and you've already got the equal 0 here. Could do that as well. But negative 6 and negative 5 are my 2 answers for n. Questions on this one? Write this one down if you would, please. 3x squared positive 2x squared is equal to 4 negative 9x. And Brandon, what do we do?
We'll first combine.
Good. First combine. We don't want all kinds of extra here, so let's combine to get
5x squared equals
that equals the 4 negative 9x. By the way, if x squared were negative, I'd want to move it over to make it positive. But again, it's positive, which is, we'll see a lot of the time, not all the time, but a lot of the time. So we're going to bring everything to the same side to set it equal to 0. What's it going to look like when I bring everything over with it?
5x squared positive 9x negative 4.
Good, and I like that he put in the descending order in that standard ax squared plus bx plus c equals 0 format. At this point, what do we got to do? Michael?
You gotta factor it in to get 5x minus 1 and x plus 2.
5x minus 1
And x plus 2.
and x plus 2. I like the 5x and 1x for sure. I like the positive negative, but 1 times 2 isn't going to give me a 4. Now I'm wondering if I copied it wrong. Did the factor? I wonder if I copied this wrong. See if I go back to where I copied it from. I don't think this is working too good. Oh, that's why. Yeah, this is one that doesn't factor. That's coming in a later lesson. Not ready for that yet. Let's try this right here. So Gavin's like, I knew it. Good job, Gavin. Let's try this equation instead. All right, so let's change that. No, I'm not going to edit it out. YouTube can just see that. Anyway. All right, so let's try this from the top. Rewind. All right, as we come to this next equation, Brandon, what do we need to do first?
Bring 4 negative 9x.
Yeah, I want to set it equal to 0. The x squared's already positive. I don't want to move that. If it were negative, of course, I'd move it to the other side, but I don't want to move that. Also bring the negative 9x over. When the 9x moves over, it becomes a
Positive.
and it combines with the 2x to get
Positive 11x.
positive 11x. The 4 comes over as a negative. It combines with nothing. There's nothing to combine with the 3x squared. What's my equation now?
3x squared positive 11x negative 4 equals 0.
There we go. And now that it's set equal to 0, what's our next step? Michael?
You gotta factor it.
Factor it. Very good. And when we factor it, what do we get here?
5 Thank you.
Me too.
Yeah. So, hold up.
Let's just take it one step at a time. Let's start with the 3x squared.
You need 3x and x,
All right.
and you're going to do 4 and 1. You need to switch them.
1 and 4.
Yeah.
You didn't say that.
You're going to do a positive at the 4 and a negative at the 1.
All right. And yeah, it looks good to me. All right, now that we've factored it, now what do I do, Audrey?
You said both equal to 0.
And again, you can do this mentally if you want to. I'm going to write the little equal 0 up top. Now, for this second one here, x plus 4 equals 0, that's easy to get the x by itself, Audrey. Negative 4. Over here, it's going to take 2 steps to get the x by itself, Abby. First, I've got to move the
1 over.
as a,
Positive.
and then I've got to,
Divide by 3.
so I've already moved a 1 over. Now I'm dividing by 3, so my answer is
1/3.
positive 1/3. Again, you can do a lot of that mentally. If not, that's fine. If you can't, you're like, no, I can't. Okay, then don't. Do it on paper. But in an ideal world, we do a lot of that mentally, move a little bit quicker. Questions on this? All right. Well, thanks to copying the wrong problem earlier, we don't have as much time as I'd like for this. I want to give you just a couple problems before we go. Write this down. If you went 3x squared, or 3 times the quantity x squared negative 2 equals 7x. And let's do this one here. Y squared negative 17y positive 40 is equal to 3y negative 56. We'll do these two and we'll call that it for today. I was in 7th grade, I forgot to put a squared on one of my area units one time. Still remember that. And then today I put a squared where it didn't belong. We've come full circle. I'm one with the force. All right. So please complete. Oh, I am now. No, not apparently I'm not. All right, for sake of time, pencils down, check your work, especially on the first one. You may not have gotten to the second one. You distribute, set equal to 0, factor, you get negative 2/3 and 3 for your answer. How many have both that first one correct? Any questions, comments on the first one? All right, looking at the second one, had a couple things to move. The 3y comes over as a negative, you get negative 20y. 56 over as a positive, 96. At this point, backwards 12, y to y, negative, 8 and 12 will get you the 20 and the net positive 96. So since it was y minus 8 equal to 0, y minus 12, moving both over, they become 8 and 12. How many of those answers on the second one, those who made it that far? Homework for this evening is to do page 95, numbers 1 through 19, the odd, and on page 96, do word problem 46. Page 95, numbers 1 to 19, odd, and page 96, word problem 46. Have a wonderful rest of your day, and you are dismissed.